What we are going to do first is we're just going to have a brief recap on completing the square. Completing the square involves us writing an expression in the form x plus a squared plus b, or x plus p squared plus q. So let's imagine that we had the equation y equals x squared plus 6x plus 8, and it asked us in the question to write it in this form here. What we need to do is the following. We need to half this coefficient here. Half of 6 is 3. We then need to subtract this squared. 3 squared is 9. And then we need to add on 8 at the end. And if we tidy that up, we would have x plus 3 squared take away 1. And I can check if this is correct is if I multiply out this bracket and I collect like terms to simplify, I should get this exact term here. So if we just check, x times x would be x squared. We would have plus 6x plus 9. And I'm taking away 1, so I would have x squared plus 6x plus 8. So these are the exact same. So if you're asked to complete the square, you need to half the coefficient of the x. You would then need to subtract that value squared and then collect like terms. That's where you recap on completing the square. From this format, what we need to do is we need to be able to identify the axis of symmetry, where that graph is symmetrical, and the turning point of that graph. So if I'm just going to take this over to the next screen, so it's y equals x plus 3 squared take away 1. If we think back to a previous video when we're looking at the actual graphs of the parabolas, a regular graph has a turning point, a regular graph of y equals x squared has its turning point at 0, 0. What we need to do is we need to find the turning point of this equation here, of this graph. So there's a couple of ways you can think about it. You can just remember the facts, or you can think about it in terms of the graphs. Let's imagine this is my regular y equals x squared with a turning point of 0, 0. This part here tells me that I need to move this graph down one place. Let's imagine I've moved this down, so it would be 0, minus 1. So here's my graph of y equals x squared. Here is y equals x squared take away 1. So I've just moved it down one place. Now if we think about this here, I've got y equals bracket x plus 3 all squared take away 1. So this doesn't do what you think it does. Okay, this does not move 3 places to the right, it moves 3 places to the left. So what I can do is I can shift this 3 places to the left. So this would be my turning point, and this would go down by 3. So my turning point would be minus 3, minus 1. Okay, so you can think about it in terms of what will happen to your regular y equals x squared graph. Okay, so I know that it's going to move down 1, so the turning point would be 0, minus 1, and I know it's going to go 3 to the left, so it's going to be minus 3, minus 1. Or you can remember that the turning point is going to be the part at the end, the constant tagged on at the end, and the negative of the constant within the bracket. One thing to note here as well is that this would be a happy parabola, because if we were to square this bracket, multiply it out, it would be x squared. So it's a happy parabola. If we think about the axis of symmetry, the axis of symmetry occurs along the turning point, along the axis of the turning point. So the axis of symmetry would simply occur at x equals -3. Okay, so here's your turning point, here is your axis of symmetry. So the axis of symmetry is the negative of the constant, the turning point is the negative of the constant in the bracket, and the value at the end. Let's look at another example. Let's imagine we have a graph y equals x plus 4 squared take away 7. So we could think about our regular y equals x squared. We know that it's moving down 7. So this would now be 0 minus 7. It's moving 4 to the left. So our turning point is going to be -4 minus 7. Or you could simply recall that the turning point is the negative of this term and the term at the end. It is symmetrical about the turning point. The turning point is going to be symmetrical about the x coordinate, so it's going to be symmetrical about x equals -4. We'll look at one more example. Let's imagine we've got the graph y equals negative x take away 3 squared take away 5. We could once again think about the direction, so this time it's negative, so it's going to be a sad parabola. It's going to go down 5, it's going to go 3 to the right, or we could simply just apply the property that we've been thinking about. So it's going to be a it's going to be a maximum turning point because it's sad. Okay, so there's going to be a maximum point on this parabola. The turning point is the negative of this value here, and then the value at the end. The axis of symmetry occurs along the x coordinate of the turning point, so the axis of symmetry is at x equals 3. Let's imagine we were asked to sketch the graph of this here. So it's in completed square form because it's got our brackets squared and a constant at the end. So we've been asked to sketch y equals x plus 5 all squared take away 7. There's like 4 steps you need to do here. Step 1 is you need to say or state the nature of the turning point. Is it a maximum turning point or is it a minimum turning point? To do that, we need to look at the term in front of the x squared. If we were to square this out and collect like terms, we would have x squared. X squared means it's going to be a happy parabola. It would be a sad parabola if it was like a negative number in front of the x squared. But here we do not have a negative here. If it's a happy parabola, it's going to be smiling. It's going to be smiling. There's going to be a minimum turning point. So that's step 1. Step 2 is we need to find the y intercept. The y intercept is the point where our parabola crosses this line, crosses the y-axis. On the y-axis, if we're to pick out some coordinates, like say 0, 0, 0, 4, 0, minus 5, in common, they all have an x-coordinate of 0. So to find the y-intercept, x equals 0, and we're going to sub x equals 0 into this equation here. It's going to be y equals 0 plus 5 squared take away 7. That's going to be 25 take away 7, which is 18. So that means that our graph is going to cut the axis quite high up at 18. Step 3 is we need to state the coordinates of the turning point. So it's going to be a minimum turning point, and the minimum turning point is the negative of this, so it will be -5, -7, and it is symmetrical about that x coordinate. So step 1, step 2, good idea here as well just to write down the coordinate. Step 3, step 4. I am not going to draw the parabola here because it's not very good to do in the tablet, but I'll show you what it should actually look like on the next screen. It will actually be easier to show what you should do exactly here. So we've got our x, our y. We know our parabola crosses this axis roughly here, let's say, 18. It is just a sketch, it does not need to be a work of art. We've got a turning point at -5, -7, so let's say that's somewhere here. All you need to do now is you need to draw your parabola connecting these 2 points. And you just need to state quite explicitly what the coordinates are. Okay, so we've got a turning point of -5, -7. It crosses the axis, the y-axis, at 18, and it is symmetrical about the equation x equals -5.